Is anybody out there? Anybody?
We are College Hill Farm.
Welcome back to College Hill Farm. Today we're continuing our series on casual and complementary prepping. But today we're going to talk about start talking about the larger things that you need to prep for. Last time we did a common sense prepping for those everyday things, power outages and things like that might occur. But now we're going to start talking about the larger things. Now, I'm a physicist, so that's made me look at those larger things in a little different way, maybe than some other folks who prep. So the first one that I'm going to do is based on a lecture that I gave back in 2012. We're going to look at asteroids and comets and their impact they could have on the planet. And I'm not going to specifically tell you how to prep for them, but I'm going to tell you what to expect so you'll know what to prep for. So before we do that though, I'm going to go through and do the same lecture I did in a physics class some 8 years ago, 8 years in 2012. And it will give us a common vocabulary when we go on with the next of it. So here's the lecture. About 8 years ago, I did a lecture in my physics class, about 2012, about the effects of comet strikes and how often they occur, comets and asteroid impacts. So let's do that, and that'll give us a little bit of information about where we need to talk about when we talk about prepping. Life on our planet is composed of about 2 million different species right now living on the planet. If you consider the oceans, and a lot of the oceans haven't been explored, especially really deep, so there's could be as many as 15 million species or 100 million. But right now we estimate that there's about 1 million to 2 million species on the planet right now. Over the years, there have been lots and lots of species. The Earth's about 3.5 billion years old, so there have been species on it for most of that time, believe it or not. But about all of those species have died off. So really, you've got to remember that extinction is a common thing, a common theme on the Earth. So why is that? About 99.8% of all species that were ever living on the Earth are already extinct. Of course, you know the big one, dinosaurs, that was the one everybody thinks about, the dinosaur extinction. But there have been all kinds of mass extinction. Now, mass extinction is just when a large amount of creatures turn up missing in the fossil record. You know, they're here and then all at once they're not here. So we can find these mass extinctions, and as a matter of fact, right now we have so many species going extinct every day. We're in the middle of a mass extinction right now on this planet. Now, marine fossils are the easiest ones to do for mass extinctions because they get deposited in the bottom of the ocean and covered, and they fossilize easier. So it's a lot easier for us to use marine fossils to do the extinction. Now, this graph, each one of those peaks represents an extinction. Now, some extinctions were more extreme. You can see there are lots of peaks. Some extinctions were minor extinctions, but they've happened over and over. But now there are 5 basically large extinctions, and when we named geologic time periods, we named them based on the mass extinction that separated the two. Okay? So what we're going to concern ourselves with is called the Permian Triassic, which is about 250 million years ago, and then the Cretaceous Tertiary, which was about 65 million years ago. That was the one that wiped out the dinosaurs. The reason we're going to look at those, of course, is they were caused by a certain thing. Now, in the Permian Triassic, the Permian Triassic, 98% of all species, 95% of all species on the planet went extinct. In the Tertiary, only about 50% of the species became extinct. The large dinosaurs, large mammals, there weren't any really large mammals at the time, but the large dinosaurs died off, and that gave rise to the mammals. What caused it? An impact. Some call them comet strikes, some call them different things, but it was an impact on the planet by either an asteroid or a comet. Now, let's get our terminology straight. A meteoroid is anything that's floating outside the Earth's atmosphere in space that can come in. A meteor is anything that comes from outside of Earth's atmosphere and plunges into the atmosphere, and they're usually made out of rock or metal or something like that, and they plunge toward the Earth, and a lot of times they melt as they come in and vaporize, and we call them shooting stars. Now, a meteorite is any part of that shooting star that hits the ground. All right? We have fall meteorites and fine meteorites. A fall meteorite is one that you see it falling and you can go over there and pick it up. A fine meteorite is a meteorite that you discover out anywhere on the planet. We have groups of folks that are in the Arctic all the time looking for fine meteorites. On August the 10th, 1972, across the Rocky Mountains, there was a shooting star that could be seen for 1,500 kilometers. We estimate that that shooting star was somewhere between 2 and 80 meters in diameter and was 1 million metric tons. It burned up before it hit the ground. But now there was a major event in 1908 in a place called Tunguska, Russia. A meteor, it wasn't a comet, it was a meteor came in, and it got so hot in the upper atmosphere that it exploded. And it exploded like a nuclear bomb. As a matter of fact, the estimate is that it was between 30 and 70 times bigger than the nuclear bomb that was shot at Hiroshima and Nagasaki during World War II. At that time, it knocked down 80 million trees. It didn't hit the ground now. It didn't make a crater. This took a long time for them to figure out what really caused it. Now, impact craters were on the moon, and Galileo noticed them. And he assumed it was from rocks and stuff hitting the moon. But on the Earth, impact craters were not considered from outer space. Everybody thought that those impact craters came from volcanoes. They were extinct volcanoes. It was some years before we determined that impact craters were a thing. And there are certain things, and I'm not going to go over all these, certain things that indicate it was an impact crater that are not common on Earth. Some big craters, Barringer Meteor in Arizona, Fram Crater, Meridian Planum on Mars. There are types of craters, and we don't need to worry about that. There's complex and all that. I'm not going to go over all the different types of craters. Middlesboro, Kentucky. I lived about 40 minutes, so I know a little bit more about the crater in Middlesboro than anywhere else. Now, the crater in Middlesboro is huge. The entire city of Middlesboro is inside the crater. The crater is about 3 miles in diameter, and you can see the whole strata as you go around the city. You see how the whole strata was changed. This is impacted about 250 million years ago. Now, this is a color satellite image that you can see the crater there in the center, and I put the name Middlesboro in the center of it. And all around it is the Cumberland Gap. A lot of you have heard of Cumberland Gap. Well, Cumberland Gap was caused by an impact crater. Now, around the world, there are 185 confirmed sites. I think there's 196 confirmed now. This information is a little bit old, and about 800 suspected impact sites on Earth. These are the things that do it: asteroids and comets. Now, the early Earth was hit by comets a lot more, and we think that might even be what brought the water and that kind of thing. But asteroids are our common enemy. They circle all over our solar system. Most of them are captured in something called the asteroid belt between Jupiter and Mars. All right, Jupiter's a great big planet. It has a lot of gravity, and it holds those asteroids in that. But now there are so many of them, they bump into each other all the time and knock each other off of their orbital course and can send them hurtling toward the sun. Now, what we have to be concerned with is something called near-Earth asteroids. And they've been working to find all those. Those are asteroids that cross the same orbital path that the Earth does. They may go in an ellipse or some other shape around the sun, and we are going in an ellipse too, but theirs will cross ours maybe 3 or 4 times. Near-Earth objects, at the time that this research was done, there were about 741 that they had done. I think it's more like 1,050 or something now. And 900 of those are classified as potentially hazardous, meaning their orbit crosses ours and you could have an impact. And there are tons, I mean tons, millions of metric tons of asteroids still out there that have never been categorized, okay, in our near-Earth orbit. The next one's comets. Everybody hears about comets. You know, that's a big thing. Everybody wants to go out with their telescope or their binoculars to see the next comet that comes by. Most famous comet on Earth is probably Halley's. They originate out at the edge of the solar system in something called the Oort cloud. There's a whole bunch of things out there, and they can bump into each other and be hurtled toward the Earth. Most of them have very long periods. They go all the way out past Pluto, you know, and then come back in. So it takes them 100 years. Some of them have 1,000-year periods, you know, 1,500 year, 3,000-year periods. You'll never see them in a human lifetime. Now, when an impact happens, the very first part is this hot thing is coming in. Now, normally, if you jumped out of an airplane, something called wind resistance would slow you to about 100 meters per second would be the maximum speed at which you could hit the ground. All right, about 100 meters per second. But comets are so big and asteroids are so big that they don't obey that. Okay, they can overcome wind resistance because of their sheer mass. So they can hit the ground at amazing speeds. The very first thing is their contact and compression, and they tunnel right into the Earth. And then they eject out all of the stuff that basically was made of Earth and the comet. And they can eject that out all the way into outer space. Now, when those comets hit, they'll hit anywhere between 30 and 100,000 miles per hour. You got to remember, the Earth is traveling around the sun at about 65,000 miles per hour. Depending on the direction of the comet or asteroid, depending on the direction, they can be traveling at huge velocities. Let's say there's one traveling at only 10,000 miles an hour toward us, but we're traveling at 65,000 miles an hour toward it. Okay? That's 95,000 miles an hour that this thing is going to hit the Earth. Okay? 25 miles in a second. So the initial contact, it burrows down into the rock and the heat is tremendous and it ejects everything out of that hole. A lot of times the asteroid, if they're big, they disintegrate on impact. Okay, and it leaves a crater, but all the stuff that the crater was made out of gets ejected out of that hole. It can actually eject out, if the comet or asteroid was big enough, it can eject out blocks as big as a bus that go up and out of our atmosphere and then fall back down thousands of miles away from that. So there can be several impact sites of huge, huge things when one asteroid comes in, if it's a big one. It can cause tsunamis, wildfires, all kinds of stuff. It's going to melt rock. During the Cretaceous Tertiary extinction, we know, because of the stuff, iridium is an anomaly on Earth. You don't find it naturally occurring. It comes from outer space. So we know an impact took out the dinosaurs. Were the dinosaurs already sickly and going down? Possibly. But the impact finished them off. It was a huge impact in Mexico, the Yucatan Peninsula. It took out the dinosaurs. And those impacts still happen. That was 65 million years ago. Keep that in mind. Now, this impact was done by a asteroid that was only about 6 miles in diameter. Okay? It was 100 trillion tons of TNT was the impact. Okay? 100 trillion tons of TNT. You can imagine how many hydrogen bombs that is. That's over 2 million hydrogen bombs worth of energy that hit the Earth. 2 million hydrogen bombs. What it did, it threw up a cloud of superheated dust. Now that cloud went all the way out of the atmosphere and fell back in. And as it did, it burned in the atmosphere and caused the entire planet to glow hot. So it burned everything below it. Okay? Unless stuff was underground, it was burning it for miles and miles and miles from this impact site. It created a tsunami that was as tall as 3,000 to 6,000 feet, and it moved at 600 miles an hour. It ignited global wildfires all across the planet, and earthquakes and volcanic eruptions happened at the same time because it so shook the planet tectonic plates. Once things had settled down, the particles remained in the upper atmosphere for years. We think maybe as many as 10 years, and blocked out the sun and supercooled the earth and killed most of the land flora, most of the plant life on land. Now, asteroids that are about 10 meters in diameter, 30 feet, they hit the Earth about once a year. Every year there's one that hits our atmosphere. Most of the time they burn up harmlessly in the atmosphere with a good light show. They can blow up there with as much energy as an atomic bomb, but they blow up high in the atmosphere. Now, things that are as big as 50 meters or 150 feet in diameter, they hit the Earth about once every 1,000 years. Okay? That's what we think hit on Tunguska, and we're going to talk about Tunguska a lot. That's what we think hit Tunguska in 1998, something between 50 and 200 meters in diameter. They can blast out huge craters, okay? An asteroid or a comet with a diameter of about a sixth of a mile hits the Earth on average of twice every million years, every 500,000 years. A comet or asteroid of a diameter of over 5 kilometers, 3 miles, hits the Earth an average of every 10 million years. Okay? We're overdue by a lot. We haven't had a major impact of the last 3 that we talked about. We had a pretty good impact in Canada, and we just discovered a new one in Greenland, a new impact site under the ice in Greenland. NASA just uncovered it with satellite imagery. But we're overdue by 8 or 9 million years. So we need to be looking at that and think about how to prepare. We are overdue indeed. Now, comets and asteroids are common in our solar system. The Earth has been in a shooting gallery for years. But most asteroids don't cause an ELE, or an extinction level event. They just don't do that. But if they're big enough, anything over a mile in diameter is going to cause a worldwide catastrophe. Okay? If it's larger than a mile in diameter, you can expect that. A mile is 5,280 feet. So if something's 5,280 feet, it's going to cause a catastrophe no matter what happens. Now, back in September, we had something 3,280 feet in diameter that passed by the Earth real close. And it could have caused a calamity, a catastrophe. I'm going to tell you that really anything bigger than 1,500 feet in diameter is going to cause a worldwide catastrophe. Let's take an example. You've got a 1 mile diameter asteroid that's going to hit the Earth. And there's a lot of them out there, okay? A lot. Lots and lots and lots. So, and it's traveling at 30,000 miles per hour when it hits the Earth. It's going to make the equivalent of a million hydrogen bombs when it hits on the planet. 1 million hydrogen bombs. It'll throw up enough dust to block out the sun for 4 or 5 years. So that is one of those things that you can try to prepare for that, but I don't know if you could ever be prepared for it. So I'm going to concern myself with the smaller stuff. Why do I concern myself with 1,500 feet? Well, 1,500 feet, something of that diameter, I know very well. 251 million years ago, at the end of the Permian, when the Permian extinction occurred, a 1,500 feet asteroid hit Pangaea in what would be known now as the Appalachian Mountains, right at the Cumberland Gap. And the city of Middlesboro, Kentucky, is right in the center of that. Well, I lived about 45 minutes from Middlesboro, so I got to look at that one pretty close. Now, that crater was huge. It's 3 miles in diameter. It threw out lots and lots of ejected stuff. I have a sneaking feeling that it was part of the Permian extinction. After watching Schumacher-Levy 9 thump into Jupiter, it was a comet coming in that broke apart and hit Jupiter in 4 different spots. It's quite possible the Permian extinction killed 98% or 95% of all life on the planet. It's quite possible that the Middlesboro explosion, the Middlesboro impact site, was one of 3 or 4 impact sites of a broken up comet that struck the Earth. Possible. Haven't found the impact sites. We were Pangea back then. There was a lot of volcanic activity afterwards. So a combination of volcanic activity and impacts could have caused the Permian extinction. I'm not saying that it did. I'm just saying that is a possibility. So we're talking about a small thing causing the Permian extinction. So let's talk about some survivable things. Well, what we're going to talk about are those things that are about the size of something that was like hit Tunguska in 1908. Okay? It was between 50 and 150 and 200 feet in diameter. I was about to use meters, but we're in the United States, so I'll use feet. It was about 50 to 200 feet in diameter, and so it was a good size thing. When it exploded, it completely destroyed 770 square miles. I mean, completely obliterated it. It exploded a mile or so above the surface of the Earth, and it obliterated 770 square miles of forest. Now, luckily it happened in an area that wasn't populated, or so sparsely populated that nobody missed the folks that got gone. Okay? It produced winds that blew out from that epicenter over 200 miles an hour for 900 square miles. Okay? So you had 200 mile an hour winds, sudden winds, gusts. So they destroyed tons and tons of stuff themselves. Not to mention the heat. There would have been a huge fireball. And that fireball would have been carried by the winds, causing forest fires all over outside this wind direction. And it was 200 mile an hour winds for 900 square miles. So imagine how much more was hurricane force winds out beyond that. So, but we're going to concern ourselves with 900 square miles and 700 square miles. Well, what would this mean if we put that on a map of the United States? So let's take a look at a map of the U.S. and show you what the devastation might look like and how much devastation would be. 900 square miles is not a lot, but it is. So let's have a look. Imagine the blue dots. The size is the size of the immediate, complete, total destruction. This area, the red dots represent the size of the wind destruction. But remember, the blue dot's always inside of the red dot. The red dot is 200 to 300 mile per hour winds going out. They're going to destroy most structures as they pass by. So, depending on where this thing hit, I've put dots all over the different places that might be affected if this should hit. Now, the overall effects. Let's talk about those. Well, what's going to happen? Well, there's going to be major mass communications blackouts, maybe countrywide. There'll be a downed electrical grid. It'll down the whole thing, possibly. Or at least within 150, 200 miles of the epicenter. Okay? There will be minor seismic activity. Depending on the composition of the meteor, there could also be radioactive activity. Okay? Radiation could be a major impact here. It could also produce an EMP that would damage the power grid that would take years to fix. So, believe it or not, even a small impactor like the Tunguska impact could cause major implications for a modern society. It could spark forest fires up to 500 miles away. Okay? It could do forest fires up to 500 miles away from the epicenter because of the hot ash that will fly out. So even a small 200-foot asteroid is going to cause major damage. And we've cataloged a ton of them, but there's a ton left that have never been seen. We don't know. What would you have? You might have 30 seconds warning before the thing hit. If it hits the ground, it'll be a whole different animal altogether. But most of those that are that size never make it to the ground. Some will burn up harmlessly in the atmosphere. They'll go through, there'll be a shooting star, there'll be a fireball, and that'll be it. But if they're composed of the right thing, they'll come through, they'll catch fire, they'll get superheated and explode with equal to 30 Hiroshima bombs. And that will cause major devastation in any area we're talking about. You know, if it hit around New York City, it could take out most of New Jersey, a big portion of New York, and most of Massachusetts. We're talking about a huge thing. Imagine what that would do to our infrastructure. Now, the latest studies suggest that there's about 3.5 million near-Earth objects larger than 30 feet in diameter. Let me say that again. There are 3.5 million near-Earth objects that are greater than 30 feet in diameter. So imagine what those could do. It's only a matter of time. So you should plan accordingly. Also, don't think that if this thing hit in the ocean that everything would be okay. Okay? Just, you can't think that way. If one of these impactors hit in the ocean and it made a tidal wave that was only 500 feet tall, okay, a 500-foot tidal wave, that would destroy our whole eastern seaboard. Most of our population of this country live within 100 miles of the ocean. Okay, the interstates are pretty sparsely populated in comparison to the states along the coast. Okay, so a 500-foot wave would be devastating. As a matter of fact, maybe an impact in the Indian Ocean, you can look at some people propose that maybe an impact in the Indian Ocean is what caused the Noah story for so many societies around the globe. So, let's take an example. Florida, the highest point in Florida is 365 feet. A 500-foot tidal wave would be 135 feet over top of that. So Florida would be covered, the entire state, by 135 feet of water. Anything survive that? Probably not. So millions of people could be affected. Now, if you like this stuff, this homesteading, prepping, do-it-yourself kind of thing, be certain to come on out to the channel and subscribe. We do this homesteading stuff every week, sometimes 1, sometimes 5 videos. Just depends on what's going on in the homestead that week. Now, if you hit the little bell when you come to the channel, it'll notify you when we upload a video. We upload every Sunday. Now, with that being said, it's time for me to get on to the next thing.